Well, hello everybody. In my first video, I've shown you how you can send data from your mobile phone to an ESP32 or Arduino-based design. I've received quite some feedback, and the main question was, okay, so how can we now send information the other way from an ESP32 to your phone, maybe to control some stuff or just to provide data? And that's exactly what we're going to do in the video today. As a basis, we'll be using the software that was written for part number 1. So the description's down below. I also added another description for the final code that you can just download it straight away. But if you want to just code along, then take the software of part 1, as I'll do here, and just go to code, download zip, and we'll open up the file here and unzip. Now we have two files in essence. We have the Arduino code that we run on the ESP32, and then we have the MIT Inventor code that runs on the phone using MIT App Inventor. We'll start with editing the code for the Arduino, and in essence we want now the Arduino to send stuff back to the phone so that we can receive this. So I'll go up and open up the Arduino app. Here it is, and basically the first thing you really want to do is just send some data back to the phone to be able to detect it. Now, we went over this code in part 1, so I'll not go through all the details anymore, but in essence here in the main loop, what we do is we get a byte from the phone, and we then decode the button and the value. So button identifier 1, 2, or 3, and then the value 0 or 1. We then set that value, digital write, to set the pin 1 on or off. Let's just send some stuff back. So if the first button is pressed, why don't we just send back a certain number to our phone? So how do you send stuff back? Well, we have this class that we defined over here, ESP32. So the class definition actually is here all the way on the top, ESP32. And if we want to now write to the Bluetooth, we can just say, for instance, ESP32.write. And let's just write 23, just a random value. Okay, so now we should be able to program this. So we'll just do upload. And now we can go to MIT App Inventor. In MIT App Inventor, we'll load the file that we just downloaded and the MIT Inventor folder. Okay, so this is the app as we discussed it in part number 1, where whenever you press a button, a command is sent to the ESP32. In order to be able to detect Bluetooth, we now need some sort of a clock that periodically pulls the Bluetooth interface to see if there's any new messages available. I already added a clock here, I see here in the bottom in the non-visible components, but just for your information, this clock is available under sensors, so it's a little bit hidden actually. You can find here the clock, and so add another one if you want, but for us just one clock is sufficient. If we go on the clock itself, so click on it, then on the right hand side you can see the parameters. So you see that the timer always fires, and the second thing here is that this timer is enabled. Below is the timer interval. And so, yeah, you can experiment with how quick you want it to be. It's in milliseconds. So let's just have a check every 100 milliseconds or so. For this application, it's well sufficient. Now we're going to, so with that's set. And now we're going to this blocks on the right top. And the idea is that we program something that periodically checks the Bluetooth interface. So let's make a little bit of space over here. So I'll just move these blocks here to the left. Then over here we have some space to define the receiver. And so if we start with the clock itself. So you go here on the left to the section clock 1, and then we want to have some sort of a function whenever the clock times. So periodically it's going to run this function. Then we need to see if there's something available in the Bluetooth interface. So here under control, we can just get an if-then statement. So the next thing we would need is to check that the Bluetooth is actually connected. And then, of course, is in addition, there must be something available. So in the logic, we'll take this AND statement, add it over here, and we'll go to the Bluetooth connection, which is over here, where we need the green one, namely that Bluetooth client 1, there should be here, is connected. Yeah, there it is. So that's the one we need. And then, of course, we want to see, are there any packets for us available? So the packets are, I think, also under Bluetooth here, bytes available to receive. There you go. Well, we can't just throw this one in over here. We need to, of course, check then if it's larger than 0. So let's see, math, take this one over here. So if this one is larger than 0, in fact, it might even work without, but it's just better to do it like this. All right, so I hope you can read. Whenever there is bytes available and the Bluetooth connection is present, then we can run this function. And what we want to do now is first just display the value that we've got. In order to be able to display it, we're going to briefly switch back to Designer. And here, let's just go here up in the top on the user interface and just take a simple label. And I'll just throw it here on the bottom. And this label I'll call, where is it here? There should be a name. A label 1 here. I'll rename this and just rename it into debug label. So let's just say label debug. Then we know that this is just something that we only use right now for debugging. Go back to blocks and we switch here on the left to the label debug. And then somewhere it has set label debug text. There you go. And we want to set now the text to whatever it received. So I will go to Bluetooth. Where is it? Bluetooth interface. There you go. Bluetooth client 1. And we will select now the received bytes, and we are just sending 1 byte. We're not sending it so quickly, so we'll just go to let's see here, received unsigned byte 1. So you can receive multiple bytes at the same time, but we're only sending a single byte. We're not sending more than a value higher than 255. So that's why I just call here receive unsigned 1 byte number. And that's all we're going to do right now. So we're going to go ahead and connect the phone, and then I'll be back with you with the screen display of the phone, and we'll see if it actually works. Okay, so phone's connected, and I'll be starting my MIT App Inventor. And, oh wait, it's blended out for you now, but over here I go to Connect AI Companion, and now switching on my phone again. Here I do scan QR code, and with that, the app will be uploaded on my phone. So first I need to select the right Bluetooth interface, which is ESP32 control. And if I now click on button 1, we should see the text below. So I click button 1. And indeed, now number 23 is shown in our debug text below. Okay, so with that, we can now send data from the ESP32 to the phone. Well, Vance asked me in addition, can I make a timer on the ESP32? and then when data is received from the phone, delay and then send something back. So let's do that with this particular app. And in particular, what we could do is that whenever you press a button, the ESP32 is now going to time for 1 second and then switch off the button again on the phone. In order to do so, let me just switch off the phone. And we're going now to go back to the Arduino code. A very straightforward way to implement the code would be just to go to this switch button. And then whenever someone switches a button on, we just delay for a second and then switch it off again. But the delay function is something you really don't want to use in Arduino because you basically stall the whole device for the amount of time you're delaying. That means that if someone presses a second button, this button cannot be activated because it's waiting for the first button to go off. So a smarter way to do that is to just register the time by using the function called millis. Millis is not an absolute time value, so an Arduino doesn't know the time of day, but it is just the time since the Arduino was started. So what we do is in the loop, we just first take notion of what the time at the moment is. So now equals millis. So that's a very simple function, and it is an unsigned long. So we need to, of course, define it somewhere. So let's just here add some more parameters. So unsigned long now. And then we want to as well add parameters for the timestamps. So we have here the timestamp for the first button, and then as well the timestamps for the second and third button. So whenever someone presses a button, that's done over here with the switch function, we don't really need this command anymore. We'll get back to that later. So what we want to do instead is we want to say that the time stamp of button 1 equals now. And of course, we don't want to do that always. Only if someone switches the button on, we want to set that timestamp. So only if the value of the button equals 1. That's more like it. So whenever someone presses a button, the timestamp's set. And the only thing we now need to do is check periodically when we can switch it off again. So we can do that outside of the ESP32 loop here. So here we can just do if the time we have right now is larger than the time for button 1, and then we want to add something like a delay. So let's define that delay right now. So we'll go here all the way on the top, and we could do this, for instance, over here, define a variable or fixed here, a delay for 1000. Going back to where we were. Then in that case, what do we want to do? Well, the only thing we need to do is switch off the pin. So I can just copy paste this over here and then replace, of course, value with 0 because we really want to write that pin to 0. And the second thing we want to do is now send back the command to the phone to switch off the button there as well. And that we do with this ESP32.write. And we're going to write 10 to the mobile phone. You might wonder, why do I want to write 10 to the mobile phone? And the reason for that is that we're just sending over 1 byte, but there's 2 pieces of information that we need to provide. First of all, we need to provide the button identifier. Is it button 1, 2, or 3? And then the second parameter we need to pass along is the value. Is it 0? Is it off? Or 1? Is it on? And so in part 1, we defined this very simple scheme that you see right now, where the first digit is the button identifier, so 1, 2, or 3. And then the second digit is the value. Is it off, 0, or is it on, 1? And we want to signal now that button 1 is off. So 1, 0. And that's why we're sending over 10. Of course, you can define your own communication protocol here, but that's just the simple one I used at the moment. All right, then what I typically like to do as well is just add a serial command. Something like button 1 timeout value is 0. So then we know that there was a timeout. Okay, and obviously we want to put this all within the if function. Now in principle this would work, but not fully yet. The thing is, whenever now the button switches off, it continues to switch itself off. Obviously we don't want that. We want it to switch off once. So let's go and fix that. And the simplest way to fix that is just to read if the port for button 1, so the LED pin, if that LED pin is still on. Only if it's on, we want to switch it off, obviously. So we can do that with a simple digital read. Okay, so in principle, this should do it. And now the only thing we need is to copy paste this 2 more times and adapt it for button 2 and 3. So I'll do that with a fast forward for you, and I'll start here on the bottom. Okay, well, the one thing that you should realize if you're copy pasting this for the other buttons, then for button 2 you'll need to write obviously 20 to the Bluetooth interface, and for button 3 30, because it's button ID 3 and the value will then be 0. And that should do the trick. So let's write this to the ESP32. So that's programmed. So let's move over to MIT App Inventor and check everything from there. In the MIT code, we want to now interpret the bytes we receive and act on them accordingly. So the one thing though is that we could also receive multiple bytes at the same time that we want to all process. So the first thing we want to do is just add a while loop in here. So I'll just throw this away briefly. I'll just do a while and then test. And so we want to see, as long as there's bytes that we need to process, we need to go through this loop. So basically, as long as we have something in the Bluetooth queue, so let's just go to Bluetooth first over here, and we have a bytes available to receive. There you go. As long as this one is larger than 0, we can now, let's just make a variable that makes it easier. This one would fit, and we can name this received byte, and we can then receive the byte with the same function we just used. And now we can interpret it, and basically we can just check, is it 10, is it 20, is it 30? Let's just keep it simple, okay? So control, we'll do an if else if. Well, it's not really what I want. Let's press this control thingy. We don't need that else. You want an else if. That's more like it. Okay, actually we don't need this debug anymore. I'll delete it. And then math. So if our variable that we receive, if that equals 10, then what we want to do, we basically want to just switch off the button. So we'll do button 1. I just select here the green, set button 1, set that image. and I just copy paste that over here. Now I don't need to, the same I do here, I select the blue thing, copy paste it, add it over here. And so if we have 20, then we need to switch the second button off. So here again, press the green to copy paste. And finally, if we have 30, then the third button should be off. And that's all we really need to do. So let's get the phone back and see if it's working. Reconnect Bluetooth. So if I now press a button, then it will after a second switch off again. If it's not seamless enough for you, you can of course go into the clock here, change the interval to something like 5 milliseconds, and then you really get an instant response. So I hope this video was informative for you. And Vince, I hope I answered your question with this as well. As usual, leave please comments down below. Likes are well appreciated, and see you in the next video.